ciespace CFD is the industry's first cloud-native end-to-end CAE solution built on our open cloud platform for mechanical engineering design and analysis. Being a cloud service, there are no plugins, no downloads. Just log in from anywhere in the world to access your models and projects. Models can be brought into ciespace from most common CAD systems, as well as using industry-supported neutral formats. Once you've got a model in ciespace, you can create projects where your workflow is executed. Workflows in ciespace support rapid iterative design, giving you the ability to leverage the scalability of the cloud to run multiple jobs and tasks in parallel. You can see that working with your model in ciespace is just as easy as working with it in the native CAD system. Here, we've extracted the interior fluid volume, and we have some questions about how much simplification we can do on this part. In ciespace, we can collaborate in many different ways. Here, I'm going to assign a task to another user, where that other user can take a look at this step in the workflow and provide feedback and comments on it. I simply initiate the task, assign it to another user, and then I can see the other user logging into the system to take a look at that task, and they can see all of the information on that specific item, in addition to the annotations, also all the settings that were created, and provide feedback back to me, allowing you to compress design cycle time by distributing your workflows effectively. Other geometry operations I can do in ciespace that make it easier to go from CAD to CAE include geometry simplification. Here we can remove things such as fillets, rounds, grooves before going to the mesher. Meshing in ciespace leverages the patented bubble mesh technology. Using bubble mesh, we're able to create hex-dominant meshes with automated boundary layer creation for superior simulation results. We also have a lot of capabilities for mesh refinement. For solution in ciespace, we leverage the openfoam solver. Openfoam was chosen for its robust support of many different physics types, as well as advanced capabilities such as turbulence models. We've also created predefined problem types that make it easier than ever to use the openfoam solver. Here, I'm using pipe flow, and I'll use the geometry selection tools in ciespace to assign wall boundary conditions, just as easily using this cloud-based application as I can do so using traditional desktop applications. Once the analysis is executed, we can then go ahead and view results. In this case, we're looking at streamlines, isosurfaces, and glyphs, and we can actually compare side by side the same analysis executed using turbulence models as well as with turbulence turned off. Once again, highlighting the ability to run parallel, multiple workflows leveraging the scalability of the cloud. The last thing we'll look at are some of the ways we can collaborate in ciespace. We already saw task assignment, and we've also talked a little bit about project sharing. We can also do node sharing via email. Finally, we're going to look at real-time collaboration where I can select a different user in my organization and initiate ciespace-based chat as well as model and whiteboard sharing. In this way, it's easier than ever to collaborate with distributed teams on complex engineering problems, resulting in better results faster. ciespace truly is next-generation engineering software, delivering engineering empowered, collaborative, open, and agile.